Hello everyone and welcome to today's Virtual Geography. Did you know that the face of our planet is moving? It's changing really slowly, like really slowly. The tectonic plates are being pushed around on top of the mantle by giant conveyor belts that we call convection currents. And these convection currents take millennia to push the tectonic plates around. And so if you haven't already seen the thumbnail, the title and that little intro bit, today's focus is on convection currents, and we'll be looking at what convection currents are, what causes them, and how the structure of the Earth is similar to a radiator. Fun. Well, yeah. Convection currents are caused by differential heating, and they exist all over the place. They're not just found in the structure of the Earth. We can find them at home, we can find them out and about. They're just all over the joint. They're here, there, and everywhere. As liquids and gases warm up, they become more excited, their particles get more energy, and as a result of that, they begin to vibrate more. And as they vibrate more, they move further away from each other. Due to this, warmer gases and liquids become less dense and begin to rise. Whereas cooler gases and liquids, they lose energy, and so their particles are less excited, they become closer together, and so they become less dense, causing them to fall. And this creates a circular cycle where hot things rise as they become less dense and cool things fall as they become more dense. It's literally the exact same scientific principle radiators at home are based upon. As air moves past the radiator, it becomes warmer and it becomes less dense and it rises towards the ceiling of the room. As it moves towards the ceiling and away from the heat source, the radiator, it begins to cool down. And so as the air cools down, it becomes more dense and falls back towards the floor of the room. This in turn creates that circular cycle we call a convection current. The air rises, hits the ceiling, begins to fall as it cools down, hits the floor, goes back towards the radiator and cycles round and round and round. Literally a convection current in principle in your home. Lovely. So convection currents are here, there and everywhere. They're found in your home, they're found in nature, but did you know they're also found deep within the structure of the Earth? You probably guessed yes, because that's literally what the whole video is about. Within the inner core of our planet, you can find radioactive elements such as thorium and uranium-238. Over time, these radioactive elements decay due to the radioactivity in a very creatively named process called radioactive decay. Who would have guessed? As these radioactive elements decay, they release billions of joules of heat energy, which in turn goes on to warm up the deepest reaches of the mantle. This causes the magma closest to the inner core to warm up, become less dense, and begins to rise in a plume towards the crust of our planet. Eventually, this magma will reach the crust of our planet in a big plume. However, because it's interacting with the solid part of the tectonic plate, it can't push its way through, so instead it's pushed sideways underneath the crust. And whilst the magma within these convection currents is pushing the tectonic plates around, the magma itself begins to cool down, and as it cools down, it becomes more dense. As it becomes more dense, it begins to fall back down deeper into the planet towards the inner core, where this whole process will restart because the inner core will once again warm up the magma. That will cause it to rise. It will then cool and fall back down, creating the convection current. In many ways, these convection currents can be thought of like conveyor belts. As they rotate, they push the tectonic plates along, just like a conveyor belt would. And so that is the idea of convection currents. It's quite simple really. Hot things rise, cool things fall, it creates a cycle, bim bam boom. Lovely video done for today. So now it's time to pack up, like the video, subscribe to the channel, don't forget to check out the worksheet in the description below, and I'll see you in the next one. Adios. The tectonic plates that make up the crust of our Earth are being pushed, moved over. The tectonic plates that make up the face of our Earth are being pushed around on top of the mantle. This. Within the inner core of our planet, I said core really weirdly then, core. Within the inner core of our planet, you can find